Hello, we are team number, and our team is conformed by Vicente Garcia, Juan Pablo Rodriguez, which is me, and Alejandro Rangel, and we are going to present you the key assignment, which is exercise number 3. Now, for the first letter, which is letter A, we need to calculate the area under the curve, using this graph, using the limits x equals to 0 and x equals to 5. But in here, we need to divide our integral in 3 parts, from 0 to 1, from 1 to 3, and for 3 to 5. And now, using the same function, we're going to integrate it with different limits. Now, once we integrate the function, we are going to solve the integral with its limits, and now we only add and subtract to get the area between the curve.
So in this one, we need to calculate the volume of the solid, and the region is bounded by x equals 0 and x equals 1. And the x-axis is revolved around x equals 0, so it's a vertical line, which means that we will need to change the function with respect to y. So instead of doing y equals x squared minus 4x plus 3, we need to isolate the x in order to be able to solve this problem. So in order to isolate the x, we first need to separate this 2 into x minus 2 to the square, which will give us an extra minus 4, because the result of this one will be x squared minus 4x minus 4, which we do not have here. So we have to add the minus 4 also outside, which means that by adding plus 4 and then minus 4, it will equal 0, so it will not matter. Then we have y equals x minus 2 to the square minus 1, which is the result. And when we isolate the x, it gives us a total of square y plus 1. Then we add 2, and that equals x. So we will do the function with respect to this one. This is a squared binomial, which means is the first term to the square. Then 2 times 2 times the square of y plus 1, and then the square of the second term. So that gives us y plus 1, then plus 4 times y plus 1 squared plus 4. And then we just solve it again. So we separate the terms, and then it's y plus 4 times square y plus 1, and we add 1 plus 4, which gives us 5. And then we're ready to integrate the function. So y to the square over 2 plus, this one is a little bit harder to integrate. So here we have the function that is 4y times y plus 1 to the 1/2, which is the same as squared. So in order to do that, we will just add 1 to the 1/2, and that gives us a total of 3 halves. And we divide over 3 halves, which just changes, and we have the 2 in the top, and then we have 3 in the denominator. So we just solve this again, and it gives us 8 times y plus 1 to the cube, that is squared, and then over 3. So we have the same function here, and then we have plus 5y, because we are. This is a squared binomial, which means is the first term to the square, then 2 times 2 times the square of y plus 1, and then the square of the second term. So that gives us y plus 1, then plus 4 times y plus 1 squared plus 4. And then we just solve it again. So we separate the terms, and then it's y plus 4 times square y plus 1, and we add 1 plus 4, which gives us 5. And then we're ready to integrate the function. So y to the square over 2 plus, this one is a little bit harder to integrate. So here we have the function that is 4y times y plus 1 to the 1/2, which is the same as squared. So in order to do that, we will just add 1 to the 1/2, and that gives us a total of 3/2. And we divide over 3/2, which just changes, and we have the 2 in the top, and then we have 3 in the denominator. So we just solve this again, and it gives us 8 times y plus 1 to the cube, that is squared, and then over 3. So we have the same function here, and then we have plus 5y because we are, and then we subtract the function, but instead of 3 we will put 0 instead of y. So this gives us 0, the other term gives us 0 as well, and in this one we have 0 plus 1, that is a 1 times 3 to the square, that's 1 as well, so it's 8 over 3. So we just solve all of this as much as we can, and then we have 9 over 2 plus 8, 4 to the cube squared, over 3 plus 15, and then we subtract 8 over 3. And the total gives us 2/29 over 6 times pi, because we do have pi multiplying here. Or if you solve it completely, it gives us 38.16666666 pi.
And now we're going to do the point C, that is about cross-sections. We're going to calculate the region bounded by this function, x squared minus 4 plus 3, with the lines equals to 0 and x equal to 1. First of all, we have that it's with rectangles. The formula of area is base times 8. The height is 2 times the base. So, first of all, we have to transform the formula like this: base times 2 base, that is equal to 2 base squared. So we substitute the function, and now we are going to multiply them. The result is here, and now that we have the complete expression, we now integrate with the limits of 0 to 1, because the section is only from 0 to 1. Now we integrate, and the result is here. We evaluate the limits 0, first 1 minus 0, evaluating this function. And when we have the result, we multiply by 2, and we have 76 over 15 units.
¡Acción!
Well, now we are going to use the Riemann sum approximation using the left Riemann sum area method to get the area of the next function. That is still the same function, x to the square minus 4x plus 3. Now, it said that has the limits of the vertical lines x equal to 3 and x equal to 5. That means that the interval is from 3 to 5 using 4 subintervals. Now, to get delta x, what we need is 5 minus 3 over 4. That is 1/2 or 0.5. Now, this method is by multiplying 0.5 plus the function to the first limit 3 plus the delta x. For example, we have this function, so we substitute the first part of the interval, that is this part, so is 3 squared minus 4 times 3 plus 3. But now we are going to add the 0.5 each time to get we are going to add 0.5 to get a previous value to the final of the interval. So this in the final is 4.5 to the square minus 4 times 4.5 plus 3. So now we solve this operation. That means it's 0 plus 5 over 4 plus 3 plus 21 over 4 And all of these results we are multiplying by 0.5, and we will get the 19/4 units that is our area.